Tanu is on, right?
Yes, yes, she is. Okay, the recording has started, so let's take it away.
Okay. Hey, everybody. Thanks for joining us for our monthly Harvest webinar series. This month's focus topic is client-server communication. And today we have Tanu with us to deliver the presentation. And please feel free to join in the Q&A part of the session once we conclude the presentation. So at this point, I'm going to turn it over to Tanu.
Thank you, Rose. Hi, everyone. My name is Tanu. Today, we will be discussing the client-server communication in Harvest. Through the webinar, we have the following agenda. Initially, we'll be starting with the architecture of Harvest. We'll be looking around what are the components that are involved in Harvest. Then later on, we'll classify these components into two parts. One will be the RT server, and other remaining components, we'll name them as RT clients. Next, we will understand how these components work with each other to fulfill whatever the request that a particular user performs, whatever operations a developer or an administrator performs. To fulfill those operations, the messages travel to what part in Harvest. We'll be covering that. And later, we will be looking into some troubleshooting techniques, and we'll be looking at some configuration settings that we can make in Harvest when we are facing some problems. At the end, we will have a Q&A. So please feel free to post your questions. If I'm not able to answer your questions, I'll surely get back to you with the answers via mail or via communities. So I'm starting now with the architecture. So inside Harvest, we say enterprise, there is a software product known as Enterprise Communicator that is the heart of Harvest. It is responsible for all the communication that happens inside Harvest. So initially we see there is a Harvest RT server and Harvest broker. RT server is the server that is provided by the Enterprise Communicator, and Harvest broker is a Harvest component which manages all the Harvest servers inside Harvest. Then we have the Harvest servers which executes all the business logic with the help of database. And we have a couple of clients which connect to the Harvest broker, and the broker relays these requests to the Harvest server and executes some operations on the database and shares the result back to the client. So overall, if we see, this is the RT server, which is the main component which will pass the messages between all these components. The other components that we see, like Harvest broker, Harvest server, this client, GUI and API, agents, all these are RT clients. So now we see, now I will understand what do we mean by Enterprise Communicator. Enterprise Communicator is nothing but it's a messaging product which will encapsulate all the system calls or all the APIs which handle the networking things. And it helps all the processes to communicate each other very quickly and very reliably. As it is based on a lot of protocols like TCP, it provides reliable communication. And this Enterprise Communicator also allows to work on different operating allows Harvest to work on communicate on different operating systems. Like we know that Harvest is supported on AIX, Solaris, Linux, Windows. So this Enterprise Communicator supports multiple platforms. And there is no need of a separate installation for this product. This comes with Harvest, and it takes care of all the infrastructure related to network. And inside a Harvest network, there can be more than one RT server and many clients. Like in the previous slide, we saw there is one RT server and a couple of RT clients. But depending upon the configuration, if we have large number of RT clients, we can have multiple RT servers serving to these RT clients. Now, what is RTServer? RTServer, as I told before, it's nothing but a message router. It will receive, let's say, there are two components. They want to communicate with each other. Component 1 will send a message to RTServer, and it will send, and the RTServer will forward that message to the other component. And the other component, when it wants to communicate with the component, the first component, it will send a message to RTServer, and RTServer will forward that message to the component. So in this way, RTServer works just like a router. And what is the RTClient? RTClient is normal process which is talking to RTServer to send messages across to other clients. If we think of Harvest, the other clients will be the Harvest broker, Harvest server, agent, client, command line. And in a particular Harvest network, one particular RTClient can only connect to only one particular RTServer. So now when we say that we have a network, we have one server, we have a couple of clients, how will the clients know that where is the server, how they can connect to that server? For that particular purpose, the server should be listening somewhere, and everyone should know its address. So now when the RTServer is started, it will determine the host name. If it is a Windows, it will determine the host names, or if it is a Linux or a non-Windows operating system, it will use the value returned by uname, and it will take that value to listen on. And by default, it will always listen on port number 5101. So this completes the picture, like how the RTServer will be listening. It will be listening on the host name on which RTServer is running, and it will be listening on port 5101 for the connections from other RT clients. And more, apart from this, there can be other configuration parameters. There are a lot of parameters like a lot of timeouts or a lot of retries that we will be covering in the later slides. All these configuration parameters can be specified in a file called RTSERVER.CM file. This file is located in the RT Home standard folder. So as an illustration, just an example, there are a lot of other parameters that we can have, but as an illustration, I have listed only two parameters which are of importance. The first parameter is server names. This parameter comes into picture when there are multiple RT servers in a network. So it specifies a list of connections a particular RT server will make to other RT servers. For example, I have a network and I have two RT servers, RT server A and RT server B. Then for the RTSERVER.CM file for RT server A, since it can make a connection to RT server B, so this server names will contain a logical connection name for this RT server B. Now, what is a logical connection name? Each connection between a client, RT client, or between a RT client and RT server, or a RT server and RT server, can be identified using a logical connection name, which is of the form protocol :node :address. By protocol, usually we means TCP. Enterprise Communicator supports various protocols, but when we see Harvest, we usually use TCP. And node will be the node name of the machine on which the RT server is running, and address is a port on which RT server is listening. So by default, it will be like TCP : the node name of the machine on which RT server is running, and : the port. By default, it's 5101, but depending upon the configuration needs, we can configure any other port as well. So next, if we see con names, for a particular RT server, this con names will be a list of logical connection name by which it identifies itself so that other clients can communicate. For example, there is a RT server. It is running on a node, let's say, test. So the string will be TCP : test 5101. So this string should be specified against the con names parameter. This means this RT server is listening on test node and it is listening on 5101 for connections from other RT clients. As we have a configuration file for RT server, we also have a configuration file for RT clients, which is called rtclient.cm. And this file will be present in the RT home folder, RT home standard folder. Like RTSERVER.cm file had lot of configuration parameters, rtclient.cm will also have some configuration parameters. For simplicity, I have only mentioned only one parameter over here, that is known as server names. It will specify a list of logical connection names with which this RT client will connect to. For example, we were discussing, I told about an example of RT server TCP:/test 5101. Now let's say I have a client which wants to connect to this particular RT server. Then the server names parameter in rtclient.cm file will be looking like TCP:/test:5101. Do we have any questions over here?
So far there haven't been any questions in the Q&A box.
Okay, fine.
Or in the chat.
Then I'll proceed. Yeah, I'll proceed to the next slide.
Sounds good.
In the previous slide, we have seen that by default, RT server will always listen on the node on which it is on the node name, host name of the machine on which it is running. But sometimes there could be requirement that when we have aliasing or we have master slave, or we have a backup server, backup RT server running. In that kind of scenarios, it is not desirable always that the RT server should listen on the host name for that particular node. In this case, there is a configuration parameter called RT host node name, which comes handy to the Harvest administrators. They can use whatever value they want, and they can create a DNS alias so that it can shift to whichever RT server they want at runtime. So how do we do this? In Windows, administrators can define one system environment variable and assign a value to the RT host node name. Now when the RT server will start, it will listen on that particular value on which on the particular value that is assigned to the RT host node name. And similar thing can be done on non-Windows. Users can define an environment variable RT host node name and assign whatever value they want RT server to listen on, and start the RT server from the same shell. So it is usually useful in the cases when we have when administrators want to have a network in which they want to create a backup RT server, or they want to switch between RT server, but only one particular RT server will be active at the moment. So now, till now we have seen like what is the RT server, what is the RT client, how does the RT server make sure that it is available to all the RT clients, and how do RT clients know that which RT server they have to communicate. Now we will go back to Harvest and see how these concepts help us in Harvest, how the things happen inside Harvest. Enterprise Communicator provides two models of communication, we can say. First is the publish-subscribe model, and second is the direct connection model. This direct connection model is a mix of publish-subscribe plus peer-to-peer communication, and the latter one we use in few transactions where we transfer the blob data inside Harvest. So if we see the publish-subscribe model, what happens in Harvest is we start with an example. Let's say there is a user who is using Workbench, and he wants to list all the packages that he has in his development state. Then what will happen? Initially, the RT server will start and it will be listening for connections. Then the broker will start and broker will register itself with RT server using a subject. If you see here, each RT client is identified using a subject. Like for broker, will be identified with PTH_broker/hostname/0. So Harvest broker will register the RT server with a subject and it will subscribe to this particular subject. What do we mean by subscribe? That means whenever RT server will receive a message which is intended for broker, that message should be sent to the broker. So Harvest broker will connect to RT server and it will subscribe to itself. That please RT server, please send me all the messages that should be sent to the broker. Then the broker will start the Harvest servers. For simplicity, I have just mentioned one server here, but there can be multiple Harvest servers depending upon a particular configuration. Then the broker will start the Harvest server, and the Harvest server will also register with the RT server, saying, see, this is my URL, PTH server, whatever is the host name on this server is running. Any message that is destined for, and it will subscribe to itself, that please RT server send me the messages that are destined for me. Now, let's say, now the client, going back to our example, now the user wants to list all the packages that are there in that particular, that are in his development view. Then he will open Workbench. He will say, I want to enable connect to broker. As soon as he enters all the broker name and the credentials, the request will go to RT server. Since the client has sent that packet to broker, RT server will find out all the clients who have subscribed to that broker, who have subscribed to receive messages intended for the broker. Then it will find that broker has subscribed, then it will forward that request to the broker. Now broker sees what all the list of active edge servers it has. It will find a particular idle edge server and it will send the request to Harvest server. Now the request will not be directly sent to the Harvest server. Again that request will go back to RT server. RT server will see, will find what are the clients that have subscribed for that particular subject, and it will forward that request to that particular Harvest server. Harvest server will receive that request. It will execute all its business logic, and if required, it will fetch the details of the packages from the database, and then it will send the reply back. Now, when the reply is also sent back, the packet will be sent to the RT server. The RT server will come to know, then it has to send it to client, because client has also subscribed to itself. In this way, the publish subscribe model works. Like all the in short, we can say all the communication that happens inside Harvest is not direct communication between any of the component. It always happens through RT server. Because previously also, as I mentioned, that RT server is just a message router. Depending upon the needs, it will route the messages to the required components. So, as I told, RT clients, whenever they start, they will register with the RT server using a subject. And as we have seen in the previous slide, these are the subjects: PTH broker, PTH server. These subjects are not a physical or logical network address, but simply a URL, which is composed of host name and PID. And whatever messages RT server publishes message to all the clients that are subscribed to that particular subject. And in this way, all the clients do not need not to worry about what all system calls they should take care, how they should establish. enterprise communicator will supply all the APIs, and they will just use these APIs to communicate with each other. Now, this was like how the basic transactions work. We have other transactions, like when we say about check-in transaction, checkout. A user wants to check in data, check out data, or he wants to compare two files. In that case, lot of data is transferred, and so to make the data fast in Harvest, for the data transfer we use direct connection model. All the all the metadata will be transferred again back to the RT server only when the actual data transfer will happen. Let's say we want to do check-in. In check-in, what will happen? Some file or some data from the developer's machine will go from the client machine, and it will go to the server, and server will store that data into the database. So when this actual data transfer will happen from the client machine to the Harvest to the database via the Harvest server, a direct connection will be made between the client and the Harvest server, and all the data related to the file. And in Harvest, we have a concept of signature files. So all the data related to that actual files and signature files will be copied to the direct connection. The publish-subscribe mechanism will also be used. On top of it, direct connection will also be used. This will speed up the actual file transfer. But one additional requirement we have when we have this direct connection, apart from the 5101 port at RT server and some ephemeral ports on which Harvest brokers and Harvest servers or clients are running, we need two extra ports, one at the Harvest server end and one at the Harvest client end, so that this direct connection can be made for the data transfer. And this direct connection is only applicable when we do blob data transfer at the time of check-in, check-out, or load repository, or when we compare two different files. Do we have any questions, or is something which is not clear?
No questions yet.
Okay. By default, this direct connection uses ephemeral ports, like some random ports which are greater than 32,000. But sometimes administrator want that this port range, they should be able to control these ports that are opened at one thing I would like to also mention, that when we talk about this direct connection, which happens only when data is getting transferred, this can be initiated by the client or it can be initiated by the server. We have a flexibility. We have some configuration parameters in Harvest which help us to control that which component will initiate this connection. So when it is desirable, like when some administrators, due to some security reasons, they want to restrict that only this particular port should be opened, this particular port should be opened at the server end of the direct connection, they can use one configuration parameter which is called as direct connect port range in their RTSERVER.cm file, and they can specify a range here. So whenever the direct connection will be made, whatever is the server end of the direct connection, like for a connection, one entity will be client which will initiate the connection, the other entity will be server. So for this direct connection, this is like the thing. When let's say this client is initiating the connection, so it will be the client for this direct connection, and suppose this is initiating the connection to this particular server, so this will be the server end. So in Harvest, we can only control what are the ports that we can only restrict the ports which will be used at the server end of the direct connection. So in that case, administrators can use this particular parameter set of direct connect port range, and they can specify. Then whenever the direct connection will be made, it will always use a port from this particular range. And how do we control the initiation of direct connection? Like how do we decide that who will initiate? That is also a configurable parameter, and it can be specified in hclient.arg or hserver.arg using the -cm option. By default, if nothing is specified, the client will initiate the direct connection, and hserver will be the server for this direct connection. And let's say both entities specify something, -cm equal to I, or both parties, they specify some parameter. In that case, whatever parameter is specified at the client end of the direct connection will be the priority. So on this, what are the firewall considerations that Harvest administrators need to think when they are designing a Harvest network? First of all, the heart of Harvest, as I mentioned earlier, is RTSERVER, is Enterprise Communicator, and RTSERVER is the main component which is responsible for all the communication. And by default, it will use 5101 port. So this particular port should always have inbound and outbound access, so that people from the outside of the firewall can connect to this particular port. This is the default port. If they have used any other port, then that particular port should be provided inbound and outbound access from the outside of the firewall. And second, if they want to restrict the ports for the direct connection at the server end of the direct connection, then these particular ports should also be provided inbound and outbound access. Otherwise, the check-in or check-out will fail. They will receive some network timeouts because the port will not be open and the direct connection will not be able to succeed. And the clients, or if we don't specify any particular port range, familial ports will be used by all the other components apart from RTSERVER, and usually that port ranges from 32,000 to 64,000. So these are the firewall considerations that should be taken care when we are designing a Harvest network. Now we have talked about RTSERVER, we have talked about how the things communicate inside Harvest, we have talked about what are the considerations we need to take care when we are having firewalls. Now other things that are very important are some timeout parameters that we have in Harvest. When we take an example of RTSERVER, there are a couple of timeouts that should be considered when we have large networks. The first parameter that I want to talk about is the client connect timeout. What do we mean by this parameter? Whenever a particular RT client sends a connection initiation to the RTSERVER, the RTSERVER should respond back to the client within this particular timeout interval. So by default, the value is 10 seconds, but it can be increased to 60 seconds if there is a large network. And next parameter which is of importance is PTM server accept timeout. This parameter comes handy in case of direct connection. Whenever the client end of direct connection initiates the connection, initiates a direct connection, the server end of the direct connection should accept that connection within this time frame. Usually we see PEC 9 error, network timeout. Then we should consider to change this value if everything is correct, like firewall ports are open or DNS server is working fine. Then they should go and look at this parameter, PTM server accept timeout and RTSERVER.CM file. They can try to increase this value to 120 seconds, or they can increase it beyond for large networks. So these are some things that we can think in, some timeouts that we can consider while we are configuring our RTSERVER. Next, we'll move to what are the timeout considerations we should make when we are configuring the RT clients in the network. Like when we are configuring Harvest servers, other RT clients, like Workbench or command line, what consideration should we take? Like I discussed just now that when we have RTSERVER.cm file, there is a client connect timeout, which will control in how much time client should respond back. There is similar for the client. Similarly, for the client, there is one parameter called _con_init_timeout. This will control how much time the client will wait after sending a connection request. If it does not receive a reply back, then it will not be able to make a connection to the RT server. So this value can be increased to 60 seconds in case of large networks. Another parameter which is related to connection handling is socket connect timeout. Whenever a socket connection is made inside Harvest or inside, we can say, Enterprise Communicator, the socket connection should be completed within a time frame of 5 seconds. So this value may be low sometimes for large networks, like if RT server is very busy, it may not be able to respond back in 5 seconds. So administrators can think of changing this value when they are seeing various timeouts. Another parameter is called server keep alive timeout. What happens is when we have a connection between RT client and RT server, the RT client expects the server to write some data on the connection, or the RT client expects RT server to write some data on the connection, or it expects itself to write something on the connection. If both the things are not happening on time, RT client will think that the connection between itself and RT server is lost. In that case, it will send a keep alive packet to RT server to make sure that it is connected to RT server. So when the RT client sends a keep alive packet to RT server, it will wait for a certain timeout for the reply from the RT server for this keep alive packet. So by default, RT client will wait for 5 seconds after sending a keep alive packet. If it does not receive any reply back within a time frame of 5 seconds, it will discard its connection to the RT server. So when some administrators are seeing that a lot of disconnects are happening in their network between the RT clients and RT server, they can think of increasing this server keep alive timeout value. We have 2 more parameters. While discussing the keep alive timeout, we discussed like that RT client expects itself to write something on the RT server, or it expects something to read from the RT server. So these 2 timeouts control like how frequently it should read or how frequently it should write. So administrators can consider to increase these values if they are having some disconnections between the RT clients and RT server. The server read timeout, server write timeout, and server keep alive timeout. These parameters they can think. Apart from timeouts, one important thing is the DNS, the domain naming service. In a network, whenever RT server is running, it is listening on one particular host name, and when clients want to connect to the RT server, they should be the DNS service that is running in that particular network should be able to resolve this node name to a particular IP address, so that the packets can flow. So that they should, if like they are not able to connect inside Harvest, then they should check whether the DNS server is able to properly resolve to a working to the IP address of the RT server, or if they have used RT-force node name, the DNS server should be able to resolve and provide an IP address for the name used for RT-force node name. Or if LDAP is used, RT server, also if LDAP server is used inside the Harvest, then the LDAP server should also be able to, the DNS server should also be able to resolve the name of the LDAP server into some IP address. Next is like the common errors that we receive support on. Like a lot of customers sometimes get network timeout. So what should they do when they receive this error? They should verify that DNS should be able to properly resolve whatever is the RT server host name or RT4 node name or the host name of the machine on which RT server is running. They should go back and look into the timeout parameters that I have described earlier, and they should try what are the recommended values are. If that is also not working, we can share the logs. RT server will write some logs, and they will be available in the temp folder. In temp folder, there will be RT works folder. In that particular folder, the logs for RT server will be there. And what do we do when we are getting PEC error 306? When we receive 306, that means RT server is not running properly. It's not up, it's down. So they should first go back and check whether RT server is up and running. Now RT server is also running, and we are able to resolve all the DNS. Then also we are not able to work, and we are getting 307. What should I do? In that case, we should go and check whether the broker is properly running or not. So these three things, these three errors are commonly seen errors when anything of them is missing. So they should go and check all of these things, and most of the times it will resolve the problem. Next, what are the tools that we can use when we are facing some problems related to the communication inside Harvest? One is Ethereal, or we can say Wireshark. It's a freeware, and it is very helpful. It's like a packet capturing tool. They can run on the machine on which they are, let's say a client is frequently having network timeouts, and whatever network Harvest administrators can check, they have verified all the things and nothing is solving them. Then they can run Ethereal on the client machine and Ethereal on the server machine as well, and they can perform the faulty case and they can share the network trace with us. Ethereal is supported only on Windows, so a similar packet capturing tool which is available on non-Windows is TCP dump. They can start TCP dump on both the client and server. They can perform the faulty test case, and they can see the packet that has flown and where the packet is getting stopped. Next, very important tool that is there is NetStat. It helps us to see how the connections are made, what connections are made between which particular component. So we can see IP address, which IP address, which port is connected to which IP address, which port. So this also helps when we are getting errors related to communication failures. Another is Telnet. Telnet, whenever a firewall is not open, and we have to make sure that firewall ports are open, users are able to access those ports from outside, they can do a Telnet to that particular port and check. So this was all that from our side. So we can have questions.
Okay, great. Very good to know. There's got to be questions out there. And it looks like we have one.
Yeah.
How can we get a copy of the presentation? I should have predicted that one. I can certainly post it, Len, or if you want, I know we're going to post the recording. Is there a way for us to include the presentation with the recording? Or should I just post it?
No, I'll take care of that, Rose. What I typically do is, in addition to posting the video of the replay, I also post a webcast recap, which has which has a link to the video and to the deck.
Okay, perfect.
So we'll make sure we package it up for everybody.
Excellent. Thank you. So there's question
Thank you,
one.
everyone.
Hold on, Tanu. I want to give folks a chance to breathe. That was a whole lot of information. Thank you very much. A whole lot of good information, and I'm sure people just need to absorb it all right now. And certainly, if you joined live or if you're listening to the recording, if you have any questions related to the information that was provided today, please feel free to send it back to us. And I'm going to say the community is probably the best way to have that interaction rather than emailing us directly. Certainly post questions to the community. Oh, I see another one coming in. Where are the RTSERVER.CM and RTCLIENT.CM files located?
Yeah, RTServer on the server machine where RTServer is installed, it is in the RT home. RT home is the environment variable. Usually, if by default it will go to whatever location tech is installed. In that, there will be a folder called standard. In that, the configuration file will be there. And similarly, RTCLIENT.CM file will be present in the RT home standard folder.
Okay, so there are a couple of RT home standard folders there.
Yeah, RT home is the environment variable. It will be the it will expand to a value with where the RT server is installed. Installation location of PIC.
Okay. Any follow-up on that question, Justin? Okay, I'm not seeing any. Okay, Justin says no. He noticed RTServer.CM on his client machine as well.
Yeah, it will be there, but it will not be used.
Okay, thanks for the clarification. Okay, any others? Going once?
I don't see anything else, Rose.
Okay.
All right. I will stop the recording then.
Thank you,
very much, everybody.